All right, everyone. So, on to subsequent topics related to the analysis of variance. Again, I'm going to break this up into a few parts because it is a more complex analysis. So, what I'm going to particularly focus on in this recording is going to be your follow-up tests from your one-way ANOVA. So, this follows hand in hand with the discussion of one-way ANOVA. So, in particular, I'm going to focus in this video on what we call your follow-up tests. As I alluded to when I wrapped up the last video, was that the significant F statistic told you that there was a difference between your three groups somewhere. But that begs the question, how do you actually figure out where the group differences came from? Were all three groups different from one another, or was there just one that really stood out? So any of the tests that you do after you've evaluated that your F is significant, you are going to do what's called follow-up tests that will illuminate where the group differences came from. And there's going to be two particular approaches for you to do this. Your planned comparisons, when you specifically think that you know which group is going to be different, and your post-hoc tests. And this is going to be a throw spaghetti at the wall and see what sticks approach. So there's going to be pros and cons to either one, so I'm going to walk you through both. Right, so the basic question from the example I walked through last time, does stress vary as a function of the situation? The three means were obviously quite different. The actual ANOVA was computed thusly using our ANOVA summary table, and we concluded that there was a significant difference between the groups. The group means were different due to the effect of the independent variable, the being in different time periods variable. So explanations of what drove that obtained F statistic to significance. There's lots of different possibilities. One could have been that the vacation group experienced less stress from the other two, and that mid-semester and finals groups were basically similar in terms of level of stress. Maybe it was the exam group that experienced more stress than the other two, and vacation and mid-semester, those are about roughly equal as well. Maybe all three groups were different. Maybe every single one was different. Vacation had the least stress, mid-semester was right there in the middle, and then the finals group was way higher. So you can't actually figure out which of these three possibilities is true by examining F alone. Yes, you can go back and you can eyeball the means and see that they are all different, but the question becomes, which of those follow-up comparisons were significantly different? We're going to want to do that. We don't just want to eyeball the different means based on the strength of the significant F. We want to actually figure out which one of these three possibilities is true. So what you could do is compare all the conditions to each other two at a time. So this basic approach of doing these follow-up tests are generally going to fall into two classes, two approaches. One is what we call planned comparisons. This is when you specifically know in advance of analysis which groups you want to compare to one another, and you have a plan for doing so. This is usually going to be on the basis of some theoretical prediction that you have. So maybe since you know about the importance of the stress hormone cortisol and its relationship to stress, you might particularly guess that the exam group is going to be way more stressed than the other two. If you have that specific prediction, you might say to yourself, my follow-up test is going to be just about comparing the exam group to the other two groups pooled together. You could also take the post-hoc comparison approach. This is when you don't have a specific plan about which groups you think are different. If it, for example, appears that all three groups had pretty different means, you might say to yourself, I would like to just make all possible comparisons. The idea is you are going to want to make a choice of which approach you want to use. So in planned comparisons, you're really picking out one group or some groups that you think are different from the others. So as I mentioned, maybe you think that the exam group will be unique and that the other two are basically the same. So what you can do is you can plan which groups you're going to compare to one another and target specifically the comparisons that you want to do. The idea is that each comparison you do is going to have its unique type 1 error rate. As I mentioned previously, when you do multiple tests one after the other, you're going to have an inflated experiment-wise error rate. So if you just do a whole bunch of tests over and over and over, you might theoretically make it easier to reject the null hypothesis. Post-hoc comparisons, on the other hand, are going to ensure that you can do as many comparisons as you want, and it's going to hold that experiment-wise error rate consistent. So a planned comparison, it's sort of akin to your one-tailed hypothesis. The idea is you're going to specifically predict which comparison you want to make, and you're just going to do that one. The critical probability value for achieving a significant planned comparison is going to be slightly lower. The idea, though, is that you specifically know which one you're going to do in advance, and it's not going to have that overinflated error rate because you know you're only going to do one. Post-hoc comparisons, on the other hand, it's that throw spaghetti at the wall approach. It's going to run all of the comparisons for you. What's going to happen, though, is when you run this analysis in SPSS, the significance value for each one of the comparisons individually is going to be held up to a stricter, harder to achieve level of significance. So it's going to be slightly harder to find a significant result using this post-hoc approach. Now, a few things to say before I show you the difference. One is that planned comparisons are slightly more complicated to do. They're more of a pain in the ass to do, let's be honest. But what you can do is you can be more targeted in your prediction, and it does have that easier to achieve significance critical probability value. Post hoc, it's going to make it harder to find significant results, but if you don't want to deal with planned comparisons, you might as well just do the post hoc approach. It's easier, it holds you to a slightly stricter bar for significance. Okay? So I'm going to show you how you do both of these. Okay? Okay, so thinking about these different comparisons, right? The idea is that we have a lot of different comparisons to choose from. Comparison one, does the exam group experience more stress than the other two? Okay, so if this is specifically going to be the comparison we want to make, and we're going in with this plan, we need to figure out a way to get SPSS to run this particular comparison for this. This is going to involve us creating what we call contrast weights that describe this particular combination or comparison. Essentially, what we're going to do is we are going to create a center around 0, and we're going to artificially create a numerical weight that places vacation and semester on one side of 0 and the exams on the other side. We say that these are weights because we need to achieve numerical balance of the groups that are on the plus side of 0 and the groups that are on the negative side of 0. Okay, this sounds a little bit complicated, and it is, but I'm going to show you how this ends up working. Okay, so first you need to figure out what the comparison is that you're doing. So, as opposed to just running your F statistic that tells you that the groups are different, you're specifically thinking which groups do you think are different, and you're pooling together the groups that you think are roughly the same. So if you just think that exam is different, place that group or level alone, and then have the other group comprised of all the other levels that you think are the same. So then what you're going to do is create a set of numerical weights for your two different groups separately. The sum of the weights for both groups should add up to the same value. Okay, so we give the exam condition a weight of 2. We'll give vacation and semester a weight of 1 and 1. That'll add it up to 2. Then what you do is you make the weights for one of those groups negative. It doesn't matter which one. You could make the -1 for vacation and the -1 for semester, pitted against a +2 for exams. The same thing would be achieved if I had switched exam as having a contrast weight of -2 and I kept vacation and semester positive. So here's a metaphor that I thought of to hopefully make this make a little bit more sense. Maybe think of it as akin to a tug of war. What you want is essentially for your comparison to create an equally matched tug of war. If, let's say, I only had two groups, it would be akin to the dogs playing tug of war right there. They're equally matched. There's two dogs of the same side on either end of the rope. That would be a weight of +1 on the right and -1 on the left. They're equally matched. The goal is to create a comparison with equal weights on either side of the center. In the context of running this analysis, you want to think of 0 as that middle point. So it's right there smack dab in the middle of that rope. These dogs represent balanced weights, right? Both of those dogs appear equally matched. You have that balance whereby you have 0 in the middle and you have equal weights on both sides. What happens though if you have a tug of war in which there's different amount of individuals on either side? Okay? Again, this is about achieving balance. In this visual, you see that there's still balance, right? There's a stalemate in the tug of war. Again, think of the middle of the rope as 0 and as your balance point. How do you create balance when you have different numbers of groups on either side? Okay, this would be the weights of these individuals depicted here, right? You can see that that guy on the right is about 3 times as big as all of those dudes on the left. So there's still balance here, which is what you want. The amount of weight overall on the right and on the left is the same. So 0 is the balance point, and you want there to be balance on both sides of 0. And this is what your contrast weights are meant to achieve. By creating those negative contrast weights for your mid-semester and vacation group, you're putting them balanced on the negative side of 0, and by giving that final exam group a +2, you're putting it on the opposite side of 0, but in balance with the other side. This is what the planned comparison does. So hopefully that metaphor made it make a little bit more sense. Again, this is just basically what you do in SPSS. Once you get to your one-way ANOVA, you want to choose that contrast option to the right. Then what you do is you sequentially add those coefficients, right? The contrast option will open up this window you see to the left, and one at a time you're going to enter those coefficients. The order in which you enter them should correspond to the way the groups are numbered, if you remember when I labeled the categorical level variable. Okay? You're going to want to enter your coefficients in the order in which the variable is coded, right? So that -1 and -1 for your vacation and your mid-semester groups, and then that 2 lastly for that final exam group. So basically what you're doing here is you're entering those contrast weights. SPSS is going to give you an error message if the sum of these values does not add up to 0. So you're going to need to make sure that, again, there's that balance whereby the weights add up to 0 overall. It doesn't matter what the weights themselves actually are. I could have given finals a weight of +1 and then just given the other two groups a -0.5. Still the balance was achieved. Okay, but it's probably going to be easier if you just copy what I did here. A -1, a -1, and a 2. Just make sure they're entered in the proper order corresponding to the way the variable was coded in the data set. Okay, so then from there, your ANOVA output is going to additionally have the results from that contrast test there at the bottom. Okay, so if you look down at the bottom of that output for contrast tests, what you see is you see value of the contrast, you see a t-value, which denotes the magnitude of the difference based on this comparison. So that t represents the magnitude of the difference between exam by itself and vacation and mid-semester pool together. And you see that it is significant. That tells you that the exam group is different from vacation and mid-semester pooled together. That's basically what the contrast result tells you. Okay, that was all pretty confusing, and I completely understand that it's hard to get theoretically. Try it out in SPSS, see that you can actually make it work, and then sort of just spend some time thinking about what all of that meant. I know that's a really tricky point, so just try and do it in SPSS and then spend some time thinking about what it is the test actually accomplishes. And then after that, you can run the way easier post-hoc test. This is again going to compare all of the groups at once. There's a lot of different post-hoc tests you can choose from. I'll show you the list. Really, they're all pretty similar. They've got minor differences in how they're evaluated and how they're computed. Really, there's a ton of them. You might have heard of the Bonferroni, which is fun to say. You can use that one. That's chill. I just have always used this Fisher's least significant difference test. So that's the one that I choose. You can play around with different ones, but this is the main one that I would recommend using. So basically, what you would do in this point is you would select, before running your ANOVA, this post-hoc option. And then from there, this is that massive list that I referred to, right? LSD is that first one that you can choose there. I recommend it. It's easy to interpret. Bonferroni, Tukey's test. Wow, what a party. Do whatever you want. All right, this is what your output would look like if you select the Fisher's least significant difference, that LSD option check there. This is what it shows to you. Basically, it's going to show you all of the possible comparisons. In some ways, it looks a little bit like a correlation matrix because you can see the comparisons depicted multiple different ways. Right, you can see at the top there, it's comparing vacation to semester and vacation to exam, and you can look over to the significance level. So if you're at the top where it says vacation under condition and semester under that second condition column, and you track over to the significance value where it says 0.011, what that tells you is that the vacation group is different from the semester group significantly. Now, if you turn your attention lower to where it says semester under I condition all the way at the left, you can see that semester can again be compared to vacation in that top row, right? So you track your attention over from left to right. You can see that that p-value is the same, right? Because comparing semester to vacation is the same as comparing vacation to semester. So that's why you're seeing some repeat p-values. Okay, another thing to note is that in this case, the post-hoc test is telling us that all of the groups are significantly different from one another. Vacation is different from semester, vacation is different from exam, and whatever the last combination was. They're all different. All of those p-values are significant. All of those groups, every single group is different from one another. Okay? So this approach is great because A, it's a bit easier. You just have to click the LSD test and then come back and interpret it. Again, you kind of can't go wrong using the post-hoc test as opposed to the planned comparison. It is a slightly higher bar for significance, but as I've mentioned before, talking about one-tailed and two-tailed tests, it's never the wrong path to choose the slightly more conservative test that makes it harder to achieve significance. So I would like you to understand how to run a planned comparison so that you could use it if you wanted to. But the post-hoc test, it's like throwing spaghetti at the wall. You basically are just trying everything out and seeing what sticks, so it's a little bit easier. Okay, so that'll do it for your post-hoc tests. We'll pick back up in the next recording where we'll talk about factorial design and two-way ANOVA.